Let's talk about solving now. So in the problems that I had in the first video, they were just simplifying problems because there was no equal sign. But now I have an equal sign, so I know that I'm going to be solving, and I'm trying to find the solution for x. What number or numbers could I put in for x that would make this a true statement? So we're going to solve. So the first thing I'm going to do is subtract 3 from both sides. So I get negative 5x squared equals negative 12. Then I'm going to divide both sides by negative 5. So I get x squared equals negative divided by negative is positive. So I have positive 12 over 5. So now I have to think about what kind of operation, like here, what did I do to get rid of this 3? I subtracted 3. Then I was down to multiplication. How did I undo multiplication? What's the inverse operation? Divide. So I have to think about the inverse operation of a square. And the inverse of squaring something is square rooting something. So I get x equals, and now I have to put a plus or minus, and I'll explain why in just a second. Whenever you square root both sides, you'll always get two answers, a positive answer and a negative answer. So I have plus or minus square root of 12 over 5. And that can be simplified into plus or minus the square root of 12 over the square root of 5. And I noticed that 12 will simplify, so I'm going to do that first. 12 is the same thing as 3 times 4. And the square root of 4 is 2. And notice the 2 goes right in front of the radical. So here's what I have right now. Plus or minus 2 square root 3 over square root 5. And now I want to rationalize the denominator. I have to get the square root out of the denominator. So I'm going to multiply by the big one. And in this case, the big one is going to be the square root of 5 over the square root of 5, because I'm trying to get rid of the square root. So on the top, I'm going to have to move down here. I have plus or minus 2 square root 3 times 5, which is 15. And on the bottom, I have square root 25, which is just 5. Now, let me go back to why we need plus or minus. If I had a problem like x squared equals 9, I have to think about what number could I put in for x and square it and get 9. 3 is one of those answers. But also, if I put negative 3 times negative 3, I would get a positive 9. So x could be 3 or x could be negative 3. So anytime we take the square root of both sides of a problem, we're going to end up with a positive and a negative version of whatever that answer is. So anytime you square root both sides, you'll get a positive and a negative answer. Let's do another example of this. So here's the next example. 4x squared minus 6 equals 42. So I'm trying to figure out what value could I put in for x that would make this a true statement. So I'm going to start by adding 6 to both sides. I get 4x squared equals 48. The next thing I'm going to do is divide both sides by 4. Because before I can square root, I need to get it down to just x squared. So x squared equals 12. And now I'm going to square root both sides. And when I square root both sides, on the left side I get x, and on the right side I get plus or minus, because I am always going to get two answers when I square root. And then I have to simplify the number 12. And I see that 12 is 3 times 4. I always want to try to pick numbers that are perfect squares, and the square root of 4 is 2. So I get plus or minus 2 square root 3. I want to caution you that when you bring this 2 out, make sure you don't put it in front of the plus or minus, because that would be 2 plus the square root of 3 and 2 minus the square root of 3 rather than 2 times the square root of 3. I'm going to go back up and check that and make sure it works. 4 parenthesis 2 square root 3 squared minus 6 equals 42. So 4 times square the 2 and I get 4. Square the square root of 3 and I get 3. This is 12 times 4 is 48. So yes, 2 square roots of 3 is a number that would make this a true statement. If I put negative in here, that would also work, because when I square a negative, it becomes positive. So those are the only two solutions for that equation. All right, here's another one. 1/3, parenthesis, x plus 5 squared equals 7. So let's think about the order that I would do the problem if I knew what x was. If I knew what x was, I would add 5, square it, take it times 1/3. So when we solve, we go in reverse order. The first thing I'm going to get rid of is the 1/3. How do we get rid of multiply by 1/3? Divide by 1/3, which is the same thing as multiplying by 3 over 1. So 3 in the numerator and 3 in the denominator cancel. So now I'm left with x plus 5 squared equals 21. The next thing I want to do is undo the square. And how do you undo a square? Square root. So over here I'm going to have x plus 5 equals plus or minus square root 21. So then I'm going to think about the number 21. 21 is 3 times 7. Both of those are prime numbers, so nothing is going to come outside the radical. So this is simplified. The next thing I want to do is subtract 5 from both sides. Now, when I subtract 5 from both sides, we want to write this in standard form, so the 5 has to go in front of the plus or minus. So my answer would be x equals negative 5 plus or minus the square root 21. Now, that's the same thing as plus or minus the square root 21, subtract 5. You just won't ever find your answer written in this order. The standard form way to write it is the constant term first and then the square root term. And the reason that's true is because this is like 5 to the first power, and you'll learn later this is like the 1/2 power. So when you write them in order, you always do biggest to smallest. So, and we'll get to that. I want to do one more with you. Let's do 1/5. One-fifth times x minus 4 squared equals 6. So again, if I worked this problem, I would do what was in parentheses first, then I would square it, and then I would take it times 1/5. So when I solve, I go in reverse order of operations. So I'm going to multiply both sides times 5. So this cancels, and I'm left with x minus 4 squared equals 30. Then I'm going to square root both sides. And when I square root both sides, I get plus or minus square root 30 equals x minus 4. And then I've got to think about 30. See if 30 simplifies. 30 would be 3 times 10, and 10 would be 2 times 5. There's no perfect number in there, and no number happens twice. So square root of 30 is simplified. So now I've got to bring the 4 over, and since it was minus 4 over here, it's going to be plus 4 over here. So my answer is x equals 4 plus or minus the square root of 30.